Hi, this is Sudeep, and I welcome you back to this wonderful journey of learning structure analysis with Start Pro. We have been discussing the use of the equations of equilibrium to solve for the reactions of statically determinate structures. We are in the third part of this discussion today. But before we go forward on this topic, please to take a moment to hit the subscribe button to join us in this wonderful journey of learning structure analysis with StartPro. In the last session, we had shown that if we take the moments of all the applied and the reactive forces that is acting on the structure, and we say that the moment of all these forces about a certain point in the plane is zero, then it would mean that either the system of forces are in equilibrium, or if the system of forces are not in equilibrium, in that case the resultant of those system of forces passes through the point about which the moment is taken. Now, based on the discussion, we had shown that if we use the equations as is shown on the screen to solve for the reactions of the structure, which by the way has been inclined with the global axis system, and we use summation of the forces in the horizontal direction to be zero and solve for the horizontal reaction at node number 1. And then if we take moments about both node number 1 and node number 2 to solve for the vertical reactions at node number 2 and node number 1 respectively, we would need to do an additional verification that whatever reactions we have obtained, and if we check that along with the applied forces in the vertical direction, that has to come to zero. Now, if that value comes to zero, then it is verified that those reactions are actually true, or those reactions are what the structure would experience when it is in equilibrium. So for that, you have to do this additional verification, which is summation of fy dash equal to 0. But I won't go into details of this because we have already discussed this in details in the last session, and I would very much request you to visit the last session to know about the details of this discussion, because without understanding that, you will not be able to understand what we would discuss today. So to go to the last session, you can click on the link that is appearing on the top right side of your screen right now. Now let us consider this particular structure that we had solved in one of our previous sessions, and this was a statically determinate structures, and we have used the equations of equilibrium that you can see on the screen to solve for the reactions of this structure, and which were summation of fx equal to 0, summation of fy equal to 0, and summation of mz1 equal to 0. So these were the reactions that we had obtained: the horizontal reaction of 36 kilonewtons, the vertical reaction of 48 kilonewtons, and a moment reaction of 36 kilonewton meter. Now, let us consider the same structure, but this time we are considering that inclined to the global axis system, to show that the horizontal and the vertical considered here are not aligned to the global axis system. We have used the terminologies h dash for horizontal and v dash for vertical. Now, remember that node number 1 had a fixed support, and it was a cantilevered frame, and that's why we have all the three reactions at node number 1. Now, in this case, the way that we had solved the reactions is pretty interesting. We have taken the moments of all the forces about node number 1, node number 2, and node number 3 respectively, and the reactions that we have solved for are exactly the same as we had obtained with the equations sigma fx equal to 0, sigma fy equal to 0, and sigma mz is equal to 0. So obviously this structure would be in equilibrium because we have already used all the three equations before. But the question now is the use of the moment equations at all the nodes is a proper way of solving the reactions? Let us find out. Now, in this case, what we have is when is summation of mz1 would be equal to 0? Only if there is a reaction force that passes through node 1 and node 2. In that case, summation of mz2 would also be 0. However, we would see that the moment about node number 3 won't be 0 because the resultant of all the forces and reactions would be acting at a distance from node 3, and hence the moment would be non-zero. The other possibility is that if the reactions acts through node 2 and node 3, in that case we will get summation of mz about node 2 as 0, summation of mz about node 3 as 0, but we won't get the summation of mz1 or the summation of the forces about node number 1 to be 0 because the resultant would act at a distance from node number 1. So this would mean that if we consider the equations summation of mz equal to 0 at all the node points, then it would definitely confirm the equilibrium of the structure, because even if there exists a resultant, it would pass through only 2 points, which would mean that the summation of the moments about those 2 points through which the resultant passes would be equal to 0, but then the other node will have a non-zero value. So that would mean that the structure won't be in equilibrium. But if in this case all the nodes, if this equation is satisfied, that is summation of mz equal to 0 is satisfied for all the three nodes, then the structure is definitely in equilibrium. So in cases where the nodes about at which we are considering the moment equation summation of mz equal to 0 are non-collinear, then it definitely means that the structure would be in equilibrium. So in this particular case, we do not need to do any additional verification checks. Thus, checking of this particular equation and solving for the reactions would satisfy the condition of equilibrium. I hope you have liked the session today. If you have, please do hit the like button and join us for the next session, which would be next week. Till then, bye bye.